Good morning, good evening, good afternoon, boys and girls. So, today's topic, EtherChannel, or also known as link aggregation. In this chapter, we'll take a look at EtherChannel. Let me just validate I am sharing the screen because sometimes I forget to do that and it is important. So, let me just double check there. Looks like everything is in order. So, time for some fun. In this chapter, we'll take a look at Ether channel, which is also known as link aggregation or port channel. Ether channel is a technology that lets you bundle multiple physical links into a single logical link. We'll take a look at how it works and what advantages of Ether channel exist. In the first example, we can have a computer connected via different Ethernet cables, connections, computer A and computer B, and they are plugged together, and there is a switch A and a switch B. That's basically what we have. Take a look at the picture above. I have two switches, two computers connected to the switches. The computers are connected with 1000 Mbps, megabit per second interfaces, while the link between the switches is only 100 Mbps, 100 megabits. If one of the computers could send traffic that exceeds 100 Mbps of bandwidth will have congestion and traffic will be dropped. There are two solutions for this problem. Number one, replace the link in between the switches with something faster, like 1000 Mbps or maybe 1 gigabit Ethernet, if you feel like replacing that to a higher speed value. The other one is add multiple links and bundle them into an Ether channel, as we can see in this second example. In the picture above, I have added a couple of extra links. The problem is that 3 out of 4 of these links will be blocked because of loop prevention. Spanning tree is a protocol that prevents loops on switch network. You'll learn about it in the next chapter. Now, let's talk about what we are doing right now. We are converting 4 physical links into a logical link, and we will have a total of 400 Mbps with the Ether channel connection. The good thing about Ether channel is that it will be bundled all physical links into a logical link with a combined bandwidth. By combining 4 times 100 Mbps, megabits per second, I know I now have a 400 Mbps link. Ether channel will do load balancing among the different links that we have, and it takes care of redundancy. Once one of the links fails, it will keep working and use that link that we have left. There is a maximum to the number of links you can use. 8 physical interfaces. Now, if you want to configure Ether channel, there are two protocols you can use. PAgP, Cisco proprietary, and LACP, IEEE standard. So we have PAgP, Cisco proprietary, and LACP, the LAC, IEEE standard. Those are the ones that we have. These protocols can dynamically configure an Ether channel. It's also possible to configure an static Ether channel without these protocols doing the negotiation of the link for you. If you are going to create an Ether channel, you need to make sure that all ports have the same configuration. Duplex has to be the same. Speed has to be the same. Same native and allowed VLAN. Same switchboard mode, access or trunk. PAgP and LACP will check if the configuration of the interfaces that you're currently using are the same. You have the Ether channel, we are using PAgP, and there is a connection between switch A and switch B. Since this is an Ether channel, we might have 4 physical connections bundled into a logical connection. If you want to configure PAgP, you have a number of different options you can choose from. An interface can be configured as on. Interface becomes member of the Ether channel, but do not negotiate. Desirable. Interface will actively ask the other side to become an Ether channel. So interface will pay passively for the other side to ask to become an Ether channel of no Ether channel configured on the interface. Let me show you the configuration of PAgP and how the different options that we currently have in this topology. So let's take a look at that. We will be using switch A and switch B. There are 2 links, fast Ethernet 0/13 and fast Ethernet 0/14. We might have to convert this into an Ether channel, bundle those 2 physical links into a logical link. That's what we will be doing. I'll use switch A and B to demonstrate PAgP. We'll use 2 interfaces to bundle into a single logical link. Interface FA0/13, channel group 1 mode. Desirable. Is now creating the port channel interface for channel 1. Interface FA0/14, channel group 1 mode. Desirable. Now we are configuring the Ether channel with these 2 physical links and converting them into a logical link. First, I go to the interface level and we can create the channel group. I'm going to use the channel group number 1. Above, you can see the different options that we have for PAgP and LACP. These are the commands that we have just executed. Now, what is next? Next, I configure on switch A for PAgP desirable mode. It is actively asked switch B to become an Ether channel this way. That's what we have just covered right now, right? What is the next step? The next step is to configure switch B with mode auto to establish full connectivity between the 2 switches. So we just configure switch A at the beginning. Now we are configuring switch B, interface FA0/13, channel group 1 mode auto. Interface FA0/14, channel group 1 mode auto. Here is the configuration of switch B. I use the PAgP auto mode, so it will respond to a request to become an Ether channel. Now we can see the port channel 1 up in both sides, in both switches, switch A and switch B. We'll see a message on your switches like mine above. The switch will create a port channel interface. What is next? We are doing interface port channel 1, switchboard trunk encapsulation .1Q, switchboard mode trunk. That is on switch A. Same commands on switch B. Switchboard interface port channel 1, switchboard trunk encapsulation .1Q, switchboard mode trunk, and that's it. We are done. I will let you know if there's more commands to it, but the port channel interface can be configured. I've set mine to 802.1Q encapsulation to become a trunk. Now, if we run this command in the switch, let's say switch A, for example, show Ether channel 1 port channel, you will be able to see the port channel is in place. It has been added successfully. The protocol we are currently using is PAgP. The desirable state for both interfaces is successfully configured, and we have the port channel successfully added. Here is one way to verify your configuration. Use the show EtherChannel port channel 1, and you will see all these details. You can also see what we are using, PAgP, in interfaces FA0/13 and 14. They are both in use of this Ether channel. What is show Ether channel summary do? Is similar, but we have some flagged information. We have the port channel name, P01, and then SU in parentheses. Do you guys know what is SU? It is a layer 2 protocol that is being in use. And then the protocol is PAgP. Also, the ports that we are currently using are FA0/13 and FA0/14. And T in this one stands for bundle in a port channel. Those interfaces are currently bundled. They are together in a logical link in a port channel. If you have many Ether channels, you can also use the show Ether channel summary command. It will give you a quick overview of all the Ether channels and the interfaces that are in use. Show interfaces FA0/14 Ether channel. There you go. You are seeing some specific information for that interface of the bundle of the Ether channel, which is FA0/14. You can see some flags. In this case, S stands for switching timer, and C for device is inconsistent state. They are together to form a flag state. First, we have the flag, but now we have the state here is U6S7. Do we have the U? What does the U stand for? Do you guys remember? It's being in use. And S is basically the device is sending a slow hello to communicate. There is the MAC addresses, there is the port, there is the flag, there is the group cap, and there is the name of this partner name, there is the switch and the port, specific port. In this third method, to verify your Ethernet channel, we use the show interfaces Ether channel command, and we are the, adding a specific port, show interfaces FA0/14 Ether channel. So we are filtering by that specific port. That's what we are currently doing. Besides information of our local switch, you can also see the interface of our neighbor switch, switch B, in my example. The last thing that I want you to know that we want to share is the PAgP. They are in different modes. You can choose. We have on, desirable, auto, and off. Alexa, stop. Those are the modes that we have for PAgP. And I have configured switch A to use desirable and switch B to use auto mode. Not all the different combinations work. So we have to get on, we have yes and no for the option of on and desirable, auto and off. So we have the combination yes, no, no, no. That is the first one, on. The second combination that we have is no, yes, yes, no. The third one, no, no, yes, no, and no. And the last one is no, 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 and no. Basically, what this means is that depending on which configuration you add in one side and the other side, it will work. So maybe we can do another table later on so we can have like a better understanding of what happens if I do desirable and auto in one side. What happens if I do on and desirable in the other side. But that's basically what we can do. I'm going to work on that later. Here is an overview of all the different options. Keep in mind that configuring your Ether channel as on doesn't use any negotiation, so it will fail if the other side is configured as auto or desirable. So the configurations that I recommend at this moment are the ones that we have seen so far. Configure one site as desirable and the other one as auto. Those are the ones I recommend for now. LACP is similar to PAgP. You can also have different options to choose from when you configure the interface. Let's take a look at those different options. So we have the following. We have the on, active, passive, and off. On interfaces become member of the Ether channel but does not negotiate. Active, the interface will ask the other side to become the Ether channel. Passive, the interface will wait passively for the other side to ask to become an Ether channel. And off, no Ether channel configure on the interface. Let's clear the drawings for a moment. Basically, we are doing the same thing. Default interface, FA0/13, default interface, FA0/14. It is basically the same thing as PAgP, but the terminology is different. Let's configure LACP. We are doing it this way. Default interface, FA0/13, default interface, FA0/14. We have configured successfully these commands on both switches, switch A and switch B. Now, no interface for channel 1, no interface for channel 1. Those has been applied in those two switches. We have successfully configured this step. Let me clear the drawings, and just move on. Don't forget to clean up the PAgP before you start playing with LACP. Interface FA0/13, channel group 1 mode active, FA0/14, channel group 1 mode active. Then I'll configure switch A to use LACP active mode. Interface FA0/13, channel 1 mode act, channel group 1 mode act passive. Interface FA0/14, channel dash group 1 mode passive. Okay, you can see it is actually passive in one side and for switch B, and the other side is active for switch A. That is another way to configure those channel groups with the active mode and the passive mode. We have successfully completed at this moment LACP in switch B. That's what we have just configured. What else do we do? Okay, now we can validate the configurations with the show ether channel 1 for channel command, and you can see the protocol is LACP. As you can see, you can use ether channel for channel command again to verify your configuration. Again, as you can see, the protocol is now LACP for both interfaces, FA0/13 and FA0/14. They are currently active. The configuration of PAgP and LACP is similar. Keep in mind that PAgP can only be used between Cisco devices, while LACP is an IEEE standard. You can use it with Ether channels with devices from other vendors like Juniper Networks, for example, or Arista Networks. We have on, active, passive, and off. We have this table where you have the on, active, passive, and off, and all the different options that we have gone over it. Now, remember this part, which is very important, depending on what you're configuring, we have to focus on the off, active, passive, and off in order to configure both sides correctly. But the on does not negotiate. So be aware that most of the time we are configuring active and passive, as we just did with our first sample. Let's clear the drawing and let's move forward. What are we missing? Show ether channel load balance is another command. We will use this command to see what the default configuration is. As you can see, our ether channel load balances based on the source MAC addresses. That's basically what we have. It is based on the source MAC addresses. Port channel load balance, and then we have the different options to configure destination IP, destination MAC, source destination IP, source destination MAC, and so on. We can use the global port channel load balance command to change this behavior. We can see if we can choose between the source, destination, MAC, and IP addresses, and all those combinations of source and destination that we have gone over before. Now, what do we have here? We have a router. Let's just name it R1. We have, let me just do something real quick. What else do we have here? We have the bundle here for EtherChannel for both switches, switch A and switch B. We have some computers, some MAC addresses. That's pretty much what we have. That's the configuration that we currently have. Let me just clear the drawing for a moment. What should you care about load balancing? Take a look at the picture above. We have 4 computers, 4, and 1 router on the right side. The default load balancing mechanism is source MAC address. This means that all traffic from one MAC address will be sent down one and the same physical interface. For example, AAA will be sent to switch A FA0/13. Triple B, the other one MAC address, will be sent to FA0/14 interface on switch A. And also, there is something else. Maybe they make an error because triple C and triple T will be sent of those interfaces as well. It's just that they just added the first 2. They didn't add the other ones for some reason. Maybe they made a mistake when they were writing the book. Since we have multiple computers, it's fine. Both physical links on switch A will be used for our Ether channel. So depending on how much traffic that computer sent, it will be close to a 1:1 ratio. It's a different story for switch B, since we only have one router with a MAC address of triple E. It will pick one of the physical interfaces, so all traffic from the router will be sent down on this interface, FA0/13 or FA0/14. One of the physical links won't be used at all. We configure on switch A, port channel, load balance, destination MAC. If this is the case, it's better to change the load balancing mechanism. If we switch it to destination MAC address on switch B, for our router to that computer, from our router to that computer, will be load balance amongst the different physical interfaces because we have multiple computers. Try different with different destination MAC addresses. This is all for this section. We have completed EtherChannel. Later on, we will develop a packet tracer lab in order to understand these concepts in real life, or a simulation, step by step, explaining these concepts. There is also in the book a GNS3 lab that you can download and install, but you will have to do your own research in order to do that. I will create a lab in order for these concepts to be more clear in the practical way, and we will go step by step explaining everything in future lessons. So for the time being, boys and girls, it's been a pleasure. I will see you at the top of success. Take care, and until next lesson, goodbye.